Alright guys, welcome back. We're going to be solving another question from the first chapter of the Beer and Johnston textbook, Mechanics of Materials, and we have question 18. And in this one, a load P is applied to a steel rod supported as shown by an aluminum plate into which a 12mm diameter hole has been drilled. And we know that the shearing stress must not exceed 180 megapascal in the steel rod and 70 megapascal in the aluminum plate. So we need to determine the largest load P that can be applied to the rod. So we have this, if you look at the figure, we have this steel rod that I'm showing in here. We have the information about all the dimensions that the force P is applying in this steel rod. So what's gonna happen is that this is gonna experience a shear stress in here. So if you wanna look at it as a 3D view, what's gonna happen is that so the force P is applying in here, and in this area in here that I'm showing, it's gonna undergo the shear stress. So if we open up this surface, we're gonna see a band that one of these sides is what we have in here, 10mm, and the other side would be the perimeter of that hole inside the steel plate that we have. So the perimeter would be pi times the diameter is 12, so will be pi times 12. That's going to give us the other side in millimeters, so 12 times pi. So the reason I'm doing this is that we're going to find the shearing stress in the steel rod. We're going to show it with S. So basically we have the force P over the area of the S, and the area of S now is pretty easy. We basically have this rectangle that we have each side of this rectangle, so pretty easy to find the area, and we can figure out the force that is applying to the rod, and we know that this cannot exceed 180 megapascal. So that was the whole story for the steel rod, and I'm gonna go with the aluminum plate that we have. So this is the aluminum plate that is the other part of the question that is asking, and basically if we look at that plate from the top, we're gonna see something like this in here that is experiencing, so that's the surface that the steel plate is applying on the aluminum plate, and what's going to happen is that it's going to go under the shear stress in these two sides, and we have again the same banding here, which is somewhere around here, and if we want to open it, we'll see again the same band. This time we have different diameter, and the diameter would be, so this will be pi times 40 again in millimeter, and the thickness would be the thickness of the plate, which is 8. So we have 8mm in here. So same story in here. We have the shearing rate in aluminum, and we have the force in aluminum divided by area, which pretty easy. We have this rectangle. We have pi times 40 times 80, and this cannot exceed 70 megapascal. So from here we can find two forces, which are the P's in here, that shows what is the tolerance for each of these two, and based on these two forces that we find, we're gonna go with the lowest, because that's going to be our safe choice to avoid failing of any of these two members. So let's start with the first one. Everything's color coded, so we're going to go with the force in the steel first. So blue. So if you want to find the force in the steel, we basically have the shearing stress time area. So 180 megapascal times the area, as we discussed, it will be pi times 12 times 10, and we're going to have 10 to the minus 6 in order to get it in meters squared, and that way we can get a force in Newton. So the mega from Pascal is going to cancel out with 10 to the minus 6. Now let's pull up our calculator. So 180 times pi times 12 times 10, 120, and that's going to give us 67.86 kilonewton. So that's the force in the steel. And now let's move on to the force of the aluminum. Again, we have the same thing, shearing stress in aluminum times the area. This time we have 70 megapascal times the area, 40 pi times 40 times 8, again 10 to the minus 6 in order to get it in Newton. And we have 70 times pi times 40 times 8. and that's going to give us 70.37 kilonewton. And as we can see, we have the force in the steel 67.86 and in the aluminum 70.37. So here we have to go with the lowest force again to avoid failing of the members. So if for example, if we go with this one, this force is going to fail this steel because it's going to make a shearing stress more than 180, so the rod is going to fail. And if we want to go with the final answer in this question, our load P has to be 67.86 kilonewton. So yeah, this is going to be the maximum force for this question and the P that we were looking for. Hope everything was clear and all this made sense. If there's any question, feel free to drop it in the comments. I'd be happy to answer those. Please make sure to subscribe to the channel, like and comment. It's going to help me to reach out to more students. And you guys take care. I'll see you in the next video. Have a good one.